Thank you, everybody. It's my pleasure to be here with you all at Republica. I first want to ask, I'm from Autodesk. Has anyone heard of Autodesk? I just love a show of hands. Any of you use our tools? I'm just sort of curious. We make software tools. If I can click here. Clicker? Clicker. There we go. Sorry. We make software tools for people who make things. Our customers are the designers, the engineers, the architects, and the digital designers who make much of the world around us. Skyscrapers, buildings, ships, bridges, cars, machinery, film, and games, including some of the most advanced things that you see on the planet, and even stories about worlds beyond. It's my pleasure to talk to you today about tools, our relationship with tools, and the shape of things to come. For the past 3.5 million years, we humans have made our tools and used them to make much of the world around us. At the same time, those tools and the things that we've created with them have also shaped us. This is the first tool made by human hands. And this is the human hand that was shaped by that stone hand axe. We've always had this intimate interplay between our tools and ourselves. Yes, we created the spear, but the spear also created in us a brain that gave us better eye-hand coordination and also an ability to think strategically enough to form hunting parties. As we've co-evolved with our tools, they have shaped our bodies, but they've also shaped our thoughts and our behaviors. We started with simple machines, using knobs and levers as well as wheels to stack stones on top of each other, which gave us the power to imagine our first types of buildings like the pyramids. And then eventually, we produced mass-produced steel, as well as rivets, elevators, cranes, even the drafting table. And these new tools help us reimagine what buildings could be, giving us the first skyscrapers. And from there, we made buildings that twist to the sky, even buildings that go to the sky and then come back. But there's two sides to every tool. Initially, tools gave us new capabilities, but ultimately they constrain our thinking. You see, the same drafting tools that once gave us those first skyscrapers also gave us cars that look like this, boxy and boring. But do you remember when cars around us all just sort of melted? This was triggered by a new tool. New software that was able to model complex curves came online all at once, and it gave designers the power to have an expression in a totally new design language. Do you remember when this meant communication? Back then, our thoughts and our conversations were literally tethered to the wall. But now, in that same hand that once held the simple stone hand axe, we hold this, a passageway to the most powerful tool that we've ever created, the digital world. And today, because of profound changes in this digital world, we're at another one of those moments where the capabilities of new tools are giving us the power to imagine, design, and create things that we never could before. In this digital world that we've created, we're working in the realm of bits now, free from the constraints of atoms, free of the laws of the physical world. As we create apps and programs and services in this parallel world, we're enjoying all of its flexibility and freedom. We're literally building castles in the sky. Think about the words that we use to describe this other place. Cyberspace, upload, and the cloud. But for all the activity that's going on up there, That's not actually the big news, because I'm here to tell you today that that other world, that parallel digital world, is about to come crashing down around us. Maybe I'll do just this. My clicker is misbehaving. It's going to come crashing down around us and make manifest in the physical world around us. Now, there's been some early strikes already, and we see that wherever the digital world touches the physical world, it affects it and changes it in a very profound way. Think about how it dematerialized the entire entertainment industry and electrified the hospitality industry, how it's all but vaporized the taxi industry. Wherever something becomes computable, it also becomes infinitely mutable. We're going to start seeing more digitization striking the world, and we're going to move from building things to compiling things. Digitization is going to transform our expectations for the entire physical world and how we design for it. It's going to change each of the things in the world, but only once we change our relationship with the tools that we use to build it. Just like that stone hand axe, the computer mouse has both expanded but also limited our capabilities and our imaginations. You see, we've always been sort of stifled and limited by this need to push our ideas through our fingertips and into our digital tools. In fact, up until now, if you couldn't draw it, you couldn't fully imagine it, and you certainly couldn't build it in the real world. We can't allow our creative imaginations to be limited in this way anymore. The fact is, we're going to have to let go of our tools. And the good news is, today we can. There's a new technology called generative design. And with this approach, we can tell the computer what it is that we want to achieve instead of drawing for it what we already know. Let me give you an example. Say I want to design something fun like the body for this quadcopter drone. Now, I know it has to be light enough to support its own weight and maybe carry a small payload like a camera or something. Generative design meets me at those goals and uses algorithms to automatically synthesize geometry using just those goals and constraints as input. Once I've given the computer those goals, I can step back and I can let it explore the entire solution space on its own, creating millions of options that all meet my goals and my criteria, including ones that I never would have come up with, all in the time that it would have taken me to draw just one. By the way, there's a reason why the drone body that the computer created looks a lot like the body of a flying squirrel. It's because the algorithms are designed to work in the same way that our bones operate, or the way that nature and evolution work. This is the first time that we have the infinite expressibility of nature available to us. For the first time outside of nature, form truly follows function. We recently used this technology on a project with Airbus to explore the airplane of the future. Now, it's still going to be a few years until something like this plane is flying, but we've already started. We made progress by using generative design to redesign one of the components inside of the aircraft, this partition panel shown here in pink. And look what it designed. A new, generatively designed, 3D printed partition that's stronger than the one that flies today in the plane, and yet only weighs half as much. This new bionic partition will fly in an A320 later this year. So what about creating the things that we design? You know, robots aren't anything new. They've been around for decades, and their physical capabilities haven't really changed very much. What has changed is that lately we've been going beyond the repetitive tasks that we've given to robots, and we're exploring new ways of communicating and collaborating together with them. We're expanding their capabilities by connecting them up to generative design and giving them the ability to do additive manufacturing. Now, this gives them a capability that they've never had before. And to explore that kind of space, we teamed up with our friend and artist, Joris Laarman, and his team at MX3D. Together, we're going to generatively design and robotically print the world's first autonomously manufactured bridge. This bridge was designed by an algorithm, guided by Joris, and this summer we'll hit print, and the robots will begin building it across the canal all by themselves. Okay, I talked about computers and robots, about thinking and acting in the world. How are computers going to perceive the world? The Internet of Things is a nervous system for the things that we create. Our bodies have a nervous system that tells us what's going on all around us. But the things we create don't yet have a nervous system, so they have no idea what's going on around them. What if they did have a nervous system? If the things that we create could actually sense what was going on, they could improve themselves over time. And to think more about that theory, we teamed up with these stunt drivers, guys who make race cars for a living down in LA, called the Bandido Brothers. We took their love for building record-breaking cars and helped them install a nervous system into one of those cars, taking a race car and instrumenting it with dozens of sensors. And then we put a world-class driver behind the wheel, and we pushed the car to its limits out in the desert. Using its new nervous system, the car recorded everything that was happening to it, all the forces that it was subjected to. And then we brought all that real-world data, billions of data points, we brought it back and put it into our generative design tool. And look what it created. It designed a bespoke chassis for that driver and those conditions on that track. It's impossible for humans to do this kind of work alone. And yet humans are capable of this when augmented by generative design, advanced robotics, and a digital nervous system. So these technologies are already shaping our physical world. I want to talk to you now about another technology that's going to act as an accelerant across all of them: machine learning. 60 years ago, a clever programmer taught a machine how to beat you at tic-tac-toe. Now, we all know that computers have gotten a lot smarter since then, and in 1997, the smartest of them, Deep Blue, beat Garry Kasparov at chess. But that was still just a display of brute force computation power. It wasn't until 2011 that things got really interesting. Rather than working from predefined recipes, Watson had to use reasoning to beat his human opponents at Jeopardy. And then, just a couple of weeks ago, AlphaGo beat the best human player at Go, a game so complex it has more possible moves than there are atoms in the universe. In order to defeat his opponent, AlphaGo had to develop a sort of intuition about the game. In fact, at one point, its programmers didn't really fully understand exactly why it was doing what it was doing. Let's step back for a moment and take a look at the time frame underneath these milestones. You can see that there's something exponential going on here. It's very exciting. In less than one human lifetime, computers have been going from playing a simple child's game to mastering a game respected as the pinnacle of strategic thinking. There's two things responsible for this acceleration. First, unprecedented degrees of parallelism due to GPUs, multi-core, and the cloud. And the second is that we've actually taught computers to teach themselves. Let me give you an example of this. Think about the classic Atari video game Breakout. Now, how did you learn how to play Breakout? Probably spending many long afternoons out of the sun trying to hone your strategy. But let me tell you how a computer learned to play at Breakout. Told only to maximize the score up on top and that it could twist this knob, a computer learned to play Breakout better than any human ever had in just one night. How did it do that? Like this. It played in computer time, playing millions of games in the course of the night, which meant it could learn faster on its own than we could ever teach it. Compare that to how we share what we know. Compare that to what we're doing here at this conference today. Just because one of us is good at a skill doesn't mean we can make our neighbor good at that same skill. But once one machine masters Breakout or any skill, it could transmit it and share it perfectly with all the other machines. They all master the skill forever. When computers get better at learning, it's going to benefit and accelerate generative design because they're going to be able to notice our reactions to what it is that they propose and be able to incorporate our unspoken preferences into the design process. AI is also going to give robots the ability to independently complete their tasks without dependence on us for explicit instructions. And for the Internet of Things, AI is going to use that input from the new digital nervous system, not just to sense the world, but to react intelligently to it. I talked about computers getting smarter. Let's talk about them getting more creative. As powerful as computers have become, we've only ever used them for that logical left brain kind of stuff. In fact, even when a sculptor or an artist or a writer is using a creative tool, the creativity is only ever coming, the inspiration, from our side of the screen. But now I think computers are really poised to transcend that barrier and make the journey into the realm of human creativity in a way that goes back all the way to Plato's theory of forms. Plato said that there are two realities, two distinct realms. The realm of the physical, which contains real, concrete objects, and the realm of the abstract, which contains forms or ideal versions of those objects. We could talk about this chair and that chair, but to Plato, they're really just different representations of one true ideal chair. Computers are actually now starting to think this way. They're becoming able to grasp the fundamental essence of a thing. Once they understand the fundamental essence of a thing like a chair, they're going to be able to help us design better because we're going to have a shared bridge of meaning between the designer and the tool. Fluency of meaning, an ability to grasp the unembodied, assimilate the unexpressed, to distill the fundamental essence of a thing. That is what is going to make computers better creative partners. And when I say creative, I mean exactly that. I mean to include the creative arts. We saw how one computer went to video game school overnight. I don't think it's unrealistic to believe that a computer could also go to art school overnight. In fact, here's one that did. It studied Rembrandt, and then it painted a brand new one. So board games, video games, even painting. Computers are getting better at human-style capabilities, intuition, generating hunches, even making creative leaps. Another way to put it is to say that computers have always been like Mr. Spock, but today they're becoming a lot more like Captain Kirk. Spock is logical and brilliant, but as we saw countless times on Star Trek, that was almost never enough to really save the day. In fact, it was usually Captain Kirk who came up with the ultimate solution to whatever problem they were facing. And it was usually driven by hunch, intuition, and creativity. We're going to need that kind of unbridled imagination to address today's biggest challenges. Fortunately for us, computers are starting to develop human-style capabilities to augment our own. So what's it going to be like when computers can generate fresh insights on their own, make independent creative leaps, just like we do? I think it's going to fundamentally change our relationship with tools and the design process. In the past, and for millions of years actually, humans have taken the role of operator with our tools, telling them exactly what to do and expecting them to do just that and no more. With things like generative design, the role of the designer becomes much more like curator, allowing the generative process in the computer to suggest ideas, and then we judge their suitability. But going forward, I think we're going to be more like mentors to our tools, coaching them and providing them with experiences. Think about how any creative professional, really any of you in the room, how you seek out constant stream of new, challenging, different experiences as a means of continually growing. Or how any parent or teacher does the same for his child or her students. In that same way, I think we're going to have to do that kind of mentoring for our increasingly intelligent and creative computers. I said at the beginning of the talk that we humans have shaped the world. Moving forward, I think we're going to shape the things that shape the world. And the question is, what then will they create? The world, in a large part, has always been made by our tools, but it's always been made in the shape of our values. The tools that I showed you are going to give us infinite expressibility. So the real question is, what values do we want to see expressed in the world? For me, I think we need to be considering values like going from constructing things to growing them, from fabricating things to farming them, shifting our focus from craving obedience from our tools to valuing and encouraging their autonomy. We'll move away from a policy of extraction to embrace aggregation. And we'll shift from creating things that are disconnected and isolated to creating things that are inherently connected and interrelated. I think we leave behind strict rigidity and embrace and encourage fluidity. These are the values, the qualities that we need to instill in our tools if we expect them to become our creative partners in the future. And when I think about them, and I think about the future, I think I know what the future might look like. The shape of things to come will be an expression of our values, our imaginations, and our humanity. The shape of things to come looks a lot like who we are. Thank you very much.
So if there's any questions, just raise your hand and I come over. All the guys with a green t-shirt will be there. So.
Thank you for your talk. Since you're in Germany, the land and the country of Adorno and Horkheimer and the dialectic of enlightenment, can you hear me?
No.
No, okay.
I'm sorry.
I'll try again. Since you're in Berlin and in Germany,
yes.
Where Adorno and Horkheimer and critical theories were very important and talked about the dialectic of enlightenment. I'm not sure if you're familiar with that concept.
Repeat it for me. I'm having a really hard
time. The dialectic of enlightenment.
Dialectic of?
Enlightenment.
Enlightenment, okay.
Right,
yes.
so that mankind created technology.
Yes.
And the Enlightenment thinking of the positive side of technology.
Yes.
But the flip side of that is the negativity of technology.
Right.
And your talk is very optimistic.
Yes.
And goes counter to this thinking about the dialectic of enlightenment. So I'd like you to speculate, not just speculate, but think through the negativity of what you've just presented and the way you talk about nervous systems when you're talking about sensors that also ingest data. So you've used this humanistic model
yes.
of the body, which you've applied to technology.
Okay.
But
yes.
I think you're sort of pushing out the negativity that
right.
Adorno and Horkheimer talk
Correct.
about. So could you please say a little bit about the negative side of your
yes,
wonderful
I do that. Yes,
shape of things to come?
Sure. I do that on purpose. And the reason I do that is because I think that, in effect, the stories we tell will those stories into existence. And I believe that fairly profoundly. So you know very well that the reason we all have cell phones in our hand is literally because of Star Trek. Because on Star Trek, Captain Kirk was able to call the Enterprise from his hand before we had any such technology. When that technology actually started to cohere and when it actually started to materialize, we already knew what to do with it and we welcomed it to be true. I think that the stories that we tell have a power to manifest themselves in the careers that we pursue and the things that we put on the planet. I think that the stories that we have today about the killer virus, the zombies that are eating cities, the apocalypse that's upon us, I think they actually create that potentiality, and I think that they condition us to welcome those sorts of realities. I therefore believe that it's the job of technology and the job of technologists like me to hurry up and get the alternative reality implemented as quickly as possible so we don't fall into those negative dystopias.
Any more questions? Please raise your hands. No. Oh, over there.
So thank you for your talk. During your talk, you asked us to be mentors, and I'm thinking in our society, mentors are people of respect or training, and now through technology, we can be, or maybe all can be mentors. Is there a guideline you can give us?
I think at the end, if I'm understanding your question, can and how should we all be mentors? Is that part of it? I tried to address that towards the end of the talk, where I said that with increasingly powerful tools, it's important that we actually consider which values we deploy as mentors into the tools. The interesting thing that I find is that we're going to have tools that we no longer learn or have to learn in order to use them, we're soon going to start finding tools that instead learn us. And so what it is that we model and how we behave for them is going to be amplified into the world. So I think in some ways, it maybe encourages us all to grow up a little and actually to behave as we want to see manifest in the world.
Over there, is there? The green guy is coming.
Hi. I was wondering when you talked about the Rembrandt computer, that still kind of, I don't want to belittle that approach or improvement, but I thought that still it was a copy of something that already existed, and I'm not quite sure if that leap from something kids play and then really strategic games for the smartest amongst us, that leap towards creating something original and new. I don't know if that's really just a matter of time, but you make it seem so logical that that's just the one direction it will go and it will come for certain. What makes you think that?
I'm sorry, could you just say a couple more words? What makes me think?
Yeah, well, why do you assume that that leap is a leap that will come? Because I think that's really what this whole debate is all about. Also, when the other guy talked about the mentor and about being a really optimistic kind of image.
Yes.
It seems to me like it's like a happy end. Don't be afraid. It will be something good, because being a mentor is really something really grown up.
Yes.
And something to like, but I don't know if that's really just you know, let's just wait for a couple of years and then we'll all be mentors. It's not automatically. So what makes you think that this will happen as you told us?
I see. I think we need it. And the reason why is because as designers today, the constraints that we're operating under aren't the real constraints of a problem. When I look around and I get to meet many designers, when I ask them what are the constraints around their problem, it really turns out to be time, money, and patience, right? So it's the boss coming in and saying, is your design done yet? Is it in budget, right? It's all due on Friday. And that is not at all the real parameter of the actual design conversation. But what we're pondering is, what if we actually had a real design partner with us that could explore many more options than we could? And it could go off and it could generate all the answers to a problem. What relationship would we then have with it? It means that as a designer, we wouldn't be left to be drawing things. We wouldn't be left even to be coming up with solutions. We'd be left with properly identifying the problem. And we'd have the conversation about what are the real goals? What are the real constraints? And I think that's the reason that designers go into design in the first place, in large part. And secondly, given the things that we have on the planet, most of which are the alpha or beta of the real building we wanted to make, or the real bridge that we wanted to make, I'd really rather understand the full consequences of our actions before we put them on the planet.
Well, I'm not sure that the computers would need us then still. So why would they take a girl like me who doesn't have time and the budget to learn from? Why would I be a mentor then?
I think that it would be interesting to find a problem that you want to solve and call some of this capacity in to apply to it. I think you're driven by some passion, you're driven by something you want to change, and what I'm trying to convey is we now have the tools to do that kind of thing and to explore more deeply and more broadly than we ever have before. It makes you more powerful.
Hi. I will take a leap into the futuristic vision, and any plans of Autodesk to take over the space industry with generative design, as this will be highly demanded there?
I have a very hard time hearing, I'm sorry. Is there a, oh, here we go. Futuristic. Maybe I could just, can I read it?
That's not what I said, yeah. So let me try to repeat it. Is there any plans for Autodesk to tackle space industry with generative design, where it will be, yes, highly demanding, yeah.
The space industry. Yes, absolutely. So one of the things that's most interesting about generative design, it can make parts, components, assemblies that actually perform extraordinarily well in strength versus weight, which is critical for the space industry. We're likely to, and we have partners that we support already that are exploring space, that are going to the moon, for example. Our partners, Moon Express, will be landing on the moon later next year. We're helping them to design parts that go on that lander. In terms of actually like going to space ourselves for a purpose of, of asteroid mining or space exploration, our company alone does not have an interest in doing that. We want to support our customers who are passionate about that industry, though.
I do have a little more of a technical question for you.
Okay.
Can you hear me?
Yes, I can.
Very good. Regarding the drone optimization problem that you showed in generative design, from a mathematical standpoint, when I look at a 2D optimization problem and I start at the same point, I will normally end up at the same local maximum or minimum, whatever it is. So how did you come up mathematically with the different design solutions that you showed?
Yes.
So did you change the parameters from the start, a starting point, or more the goal that you had in mind? Which did you do?
Right. So it does, first is to say that it does a design exploration to make sure that it's not going into a local minimum, right? There may very well be a global minimum somewhere else. So it has to stochastically explore, to answer your question sort of mathematically. But an even better answer is that it's generating answers for parameters that I have not explicitly stated. So material, for example, or cost, or manufacturability, or even kind of manufacture. These examples that I was showing typically had been 3D printed, but there's no reason generative design can't be used for injection molding, or for casting, or for milling, or for other traditional techniques. So what's important to know is that all of those different kinds of techniques can still be explored without having to set them first, the way we do in today's design process. Yes, the question was, some of those manufacturing processes had inherent boundaries in them that we had set
I can repeat it if
themselves.
you want.
Go ahead.
So the casting, whatever, molding you said, those are actually things that we invented for ourselves.
That's right.
And so the machine knows that it has these things to its, or in its equipment.
Yes.
But how can it actually find new solutions for that too?
New solutions for different kinds of manufacturing, do you mean? One of the things that I find most exciting is in the additive space. So in additive manufacturing, today what we mostly see is making things all out of the same material. So yes, you get a unique shape or a unique form, and we could 3D print any form we want, but we're still just using one kind of material. One of the most promising avenues that I see in manufacturing is using more than one material in one part. Because we're putting down material drop by drop, if you want to think of it that way, we have the possibility of putting a different drop of material at every point in space. That is going to be impossible for humans to grapple with in the terms of design. We are never going to be able to keep track of that possibility and that level of information. It's perfect, though, for generative design. Generative design can very easily replace the mechanical hinge that I have on my glasses with a gradient material that goes from stiff to flexible to stiff, all in one part. So I think we're going to see a novel type of manufacturing arrive in the future. At the same time, I want to acknowledge that we already have manufacturing capability deployed on the planet. We have different manufacturing plants that already do injection molding and casting and milling and whatever else. The front-end design process that feeds them could be improved to maintain design intent better. And there, too, I think generative design is helpful in what we've already got. Thank you for the question. Any more? Okay. Yes.
Thank you for your talk. I have a question about frontiers, because in your talk you focused on space, on computer-generated content,
Yes.
computer-generated design.
Yes.
Sometimes you compare computers to nature.
Yes.
I missed something. You spoke about construction. What's about deconstruction? Nature thinks about deconstruction things, about waste management, reuse.
Yes.
I think you are firm with the terms of circular design from cradle to cradle. Where do I found this in your super wide vision?
Yes, that's fantastic. Thank you for the question. One of the things that I lament the most about our design and manufacturing process today is as soon as things come off the back end of the conveyor belt in the manufacturing process, they're already dead. We're making dead things as fast as we can. They don't change, they don't modify themselves, they don't have a life, they don't do anything. And in fact, we don't really contemplate what that end point is or how it could reconnect. I do think that the possibility for broadening the vision of the design process is now becoming available. What I would like to see is maybe the next cell phone, for example, is not one with a better camera, but it's one that is compostable. So maybe we're making things that take in mind what this lifetime looks like. Truly, in the fullness of time, and this gets a little crazy, but what I'd really like to do is take the entire generative process and put it into the object itself. And that looks a lot like life. We're getting to the point where we're able to manipulate DNA to cause cells to perform different functions. Cells actually are themselves computers and factories in one small unit. It is theoretically possible that we can make a different kind of life or a lifelike object that modifies its behavior over time, produces a different morphology, and I think most importantly, intersects with nature instead of trying to crush it. Thank you. Yes. It's back here.
If we are manufacturing machines which are more intelligent than us, maybe, and can do everything better than us, why should that machine be interested in make me more powerful? And if it can make persons more possible, who will be those persons? Will we have a monopoly of people who control these machines, if there's any control at all?
Yeah. I don't know that I have all the great answers to those questions. I think actually that is part of the dialogue that we've got to engage in. It's my objective to show the things that are actually coming and make sure that everyone is equally aware of them so we can have conversation. That said, I think that the reason I am excited about this, and I want to share the excitement with you, is these tools give us the power to understand the consequences of our actions before we undertake those actions. And I think that's critically important when we've got diminishing natural resources, rising cost of energy, and a whole lot of strife in the world. If we could understand what might come next if we plan a project, or what the long-term effects might be, I think we can make better decisions. So what I'm really showing is something that allows us to make better decisions. I don't know another way to describe or delegate that power other than I wish it to be democratized for everyone to have so we can all be participating in the process.
Hello. I'm not sure if this question even applies, but talking a little beyond the boundaries of design in the physical characteristics of design, do you think generative design could be applied to concepts such as social understanding of stagnant social systems in some way? Like, for example, the education industry, for example, is sort of reaching a plateau, and there are several data points that can be got out of understanding what happens within personalities growing within a school environment. Do you think a system such as generative design, not specifically that, could be applied to sort of reform, restructure stagnant social systems?
I have no idea.
Right. Thanks.
Over there.
Hi. I was wondering, since you talked about a compostable phone and sort of the changes in our approach to how we handle resources and our limited amount of resources on the planet, if you could see the generative design or a comparable system applied to a more global approach to resource management and maybe even a shift in the sort of economic underpinnings that lead us to a more, wholesome and more future-oriented research management system, a sort of global AI or computer-based research management system.
I think those things are already happening and they lack the proper mentorship. The fact that financial markets are already governed by these algorithms points to that fact.
Thank you.
We have over here the guy with the gray t-shirt.
Yes.
Yeah. Hello. I've seen some of your further presentations, and I'm interested in. You spoke about we're entering the new age, which is called the age of imagination, and we are leaving this age of information now. So, my question for you is, what would be your favorite project you always wanted to have, or you always wanted to design in the future, or just?
It's hard to pick one, honestly. I can go in a number of different angles. I think the projects that I'm probably most excited about are the ones that eliminate the greatest amount of waste first. So letting aside the exciting or exploration or experimental or inspiring ones, just the ones that stop the waste the quickest are the ones that I think inspire me the most. When I look across the building industry, for example, or the way that we build infrastructure, everything from airports to roads to bridges to buildings, and we realize that just in the construction of it alone, 30% of the input goes to waste. That to me is unconscionable. And then if I think about the fact that buildings are designed without really a keen view of how they're going to be operated for 30 years and never monitored, that's another opportunity to close the gap and eliminate more waste. And I'd like to see those things happening first. That's not to say that there aren't other exciting and opportune things that we can go after, but if we're going to get to that future, I think we have to stop squandering it today.
Hello.
Yes.
Thanks for your talk. It was quite interesting. One thing I found missing from your talk, for me itself, it's computing power of the problems. Like you showed the car, and the main problem is not the algorithms or having the tool, is like having the computing possibility. And since you're a company which is famous kind of to find your software cracked on the web, so do you have any policy who you are giving your software, your tools? And do you have any moral obligation towards governments? Because some governments use your tools to make museums and hospitals. Others make them to make design jails, safe jails. Now with generative design, other possibilities. Any moral obligation policies in your company? Thanks.
Yeah. It probably goes back to the company mission statement I showed you on the very first slide. Our mission is to help people imagine, design, and create a better world, not a more screwed up one. So every one of us does have a moral obligation inside the company that we exercise every day. I will tell you a couple things related to specifics in your questions. First of all, the tools that I've shown here, they only run in the cloud. They absorb so much computing power, require so much computing power, they're never going to run on the desktop or your laptop. They're meant to be deployed across thousands to millions of machines. The tools and their access that we grant are not piratable. These tools can't be pirated as our desktop software would have been. So it's very challenging for them to fall into the wrong hands. We have a list of those governments and those countries for which we are forbidden to sell to, and it lines very closely with our moral thinking and our moral obligations. So we actually have a better set of controls now with these tools than we have had historically in desktop software.
Hi. With generative design, do you think it makes current technical design education redundant? And if so, what skill set do you think the next generation of designers will need?
It's a great question. I don't think that studying the way things have been done is ever redundant. I think it actually helps understand the pathway and how we get to things, and it develops kind of an intuition in one's own mind. So I would never take the pen out of a student's hand. I think that connection is actually important in some way. Going forward, though, I think the things to study actually wind up becoming a lot more broad rather than narrow. And I think that what we can really bring to problems and what we can bring to these tools is a breadth of understanding. I think those are the types of skills that are going to be most valued in education by students and by the world moving forward. So I would encourage people, and when I speak to designers, I typically tell them, go somewhere else. When they come up to me after a talk and say, I agree with everything you said, I said, fantastic, stop talking to me and find an area or a field that you disagree with and explore it thoroughly.
First of all, I'd like to say that I really like your positive outlook on the future, combined with the message that it's still us to create it.
Yes.
But you've also mentioned that in the financial sector, algorithms are already, managing most of the business.
Right.
And I think that's especially the sector that serves best as an example how algorithms can destroy value. Because due to automized decisions of selling and buying, in minutes, millions are wasted.
Yes.
So how do the algorithms and how do we need to change the algorithms and us to create a better future?
You know, I'm a CTO. The T is for technology. I wish I were a CPO, P for philosophy, or maybe ethics or something. I don't have that training to say what it takes for society to shift its values so that we are all operating in the same direction and we're not looking for short-term returns or exercising and growing our own power and wealth at the detriment of others. I don't know how to align those sorts of values socially. That's not in my training. I wish it were true. It's why I'm in this field and I'm not in that field. I don't think that I would be successful either for myself or for the field if I were over there, truthfully. So I'm trying to make the help where I can. Sorry for the crummy answer. It's an honest answer.
Hello, and thank you for your talk. I wanted to build on previous questions because with this great technology built in the cloud and with this list of people who have access to it and who don't have, don't you think that this is a limitation about who can ask questions to the algorithm? And wouldn't we end up with much better results if more people had access? I know that with this architecture, you cannot just make it open source and give to everybody on every computer, but maybe creating some simpler version, some more accessible version, and just allowing people from different places. Because today, for example, I was in a talk from Hackerspace from Burkina Faso. They were able to ask questions. Nobody from the West would be able to ask about how to help. And I think this will be very very widespread in the design of things.
I like your question. You're really asking about inclusion, which is also something that we value at Autodesk. So I should let you know, sometimes when I start talks, I say, who knows Autodesk? Who uses our products? Who pays for them? Okay. It should be known, every student on the planet, 680 million, have access to all of our software for free. So that's pretty important. So already those people who are young and making inquiries and really have, I would hope, a optimistic or at least possibility view of the future, already have access to our software. Second thing is, companies that are of smaller size, pre-revenue, et cetera, typically wind up getting breaks and access to our software for free or radically reduced price. It's the way that Autodesk makes its money is from the larger companies who are already using design as a value-generating element inside of their business. You should also know that Autodesk has several 100 million consumer users of our consumer products that we've made specifically for people who aren't professional designers in their day jobs, but have a need or a desire for creative expression. And we give those tools to them, often for free, or as apps you might find on the App Store, 123D series or Tinkercad. These are free or apps that cost just a few dollars. So it's always been our design or our mission to include as many people in the design conversation as possible. And in fact, I think the more people that can participate in design, the more robust kinds of questions we can pursue, and the better, more robust answers we will manifest. Fully agree.
Thank you. Just one follow-up. Are you going to give people access to that kind of generative algorithms? Any kind of small, limited access for, as you said, students and small companies?
Yeah.
Thank you.
So I would hope that, just to be perfectly clear, we haven't worked out the business model for exactly how we'll use infinite computing and in generative design. It would be my hope, though, that we've got a way for people to come in on an on-ramp, and maybe there is some kind of, you can't do everything, right, with the base tool, but you can do some things, and you could do meaningful things. And then when you dedicate your profession or your product or whatever to generative design, that's actually where we're aligning, because we can agree that there's big value, and we can participate in the value that you're creating. So we've always tried to make that curve, and I think we'll do the same thing for generative design.
So I think that's it. Thank you very much for your answers, for your time. Jeff Kowalski of Autodesk. Thank you.